Okay, so now let's look at this initial value problem. So the auxiliary equation is r squared plus 6r plus 13 is equal to 0. And we use the quadratic formula. And the r is equal to -6 plus minus square root of 6 squared minus 4 times 1 times 13 for AC over 2 times A is 1. And so we get -6 plus minus square root of -16. So square root of -16 is 4i. So you have -6 plus minus 4i and whole divided by 2. So when you divide both of them by 2, the -6 becomes -3 and the 4i becomes 2i. So the general solution in complex roots we know is C1 e to the at cos bt plus C2 e to the at sin bt, where a is -3 and b is 2. So let's just copy it and substitute the constants. A is -3 and b is 2. And now we use the initial conditions. We also have a condition about the derivative. So let's take the derivative right now. So y prime y prime t is equal to, so we will have to use the product rule here on the first term. C1 is a constant. You can think that the C1 is going along with the e to the -3t. It doesn't matter whether you include it with this one or that one, or just put it outside. So a derivative of the first function would be -3c1. So -3 c1 e to the -3t, and then you keep the cosine 2t as it is. Okay, so that's the first part of the product rule, the derivative of the first function times the second. And then you keep the first function, you keep the plus c1 e to the -3t, and you take the derivative of cosine 2t, that's -2 sine 2t, so that will give you negative. And keep this one. And the cos 2t derivative was 2 sine 2t, so we can even put the 2 outside here. Okay, so that is just the derivative of the first term. So similarly, for the second term, the derivative of c2 e to the 3t is 3c2 e to the 3t. So 3 c2 e to the 3t. And then you keep the sine 2t as it is. And then plus, and now you keep the c2 e3t as it is. And you take the derivative of sine 2t, which is 2 cosine 2t. I can put the 2 here. And cosine 2t. Okay. And this one also we can write as y of t. And now the first condition is y of 0 is equal to 2. So y of 0. And this would become e to the 0, which is 1. And this is cosine of 0 when you put t equal to 0. And cosine 0 is also 1. So this will also go away. And then this also goes away. E to the 0 is 1. And sine 0 is 0. So all of the second term goes away. So y0 is just c1, right? You put t equal to 0. This is just c1, and this part is 0 because of sine 0. And y of 0 was given to be 2. So actually we have c1 is equal to 2. And then when you do the y prime 0, y prime 0 is negative 5. So y prime 0, and c1 we already have to be 2, so you can substitute 2 here. E to the 0 is 1, cos 0 is 1, so these two just go away. 1 times 1 is nothing. Okay, and here c1 can be replaced by 2. C1 can be replaced by 2. We already had a 2, so it was 2c1, so 2 times 2. And e to the 3, e to the 0 is 1, and sine 0 is 0. So actually this term just goes away. And so this one has gone away. And this one is also sine term, that will also go away. It's cos sine 0 is 0. And then here you will have 2c2, 2c2, e to the 0 is 1, so this will go away. And then cos 0 is 1, so that will also go away. So, and okay, here e to the 0 was 1, so this e to the 0 also goes away. So you just have negative 6 plus 2c2, and then y0 is equal to negative 5. So you have negative 6 plus 2c2 equals negative 5. So this gives me 2c2 equals negative 5 plus 6. Negative 5 plus 6. And so 2c2 is equal to 1. And so c2 will be 1/2. c2 be 1/2 or 0.5. We have both the constants. So C1 was 2 and C2 was 0.5. So this is the answer.